Afternoon, everybody. My name is Garry Keenor. I work here at Atkins Realis in Swindon, and I'm professional head for electrification for Atkins Realis. My colleague Paul Hooper is technical director, career electrification engineer, and very much working in a similar space to me. So we're going to be talking to you about cost-efficient electrification work we've done specifically around sectioning and switching of overhead line. So for those of you who are not familiar with what sectioning and switching actually is all about, so if we think about Paddington to Bristol, it's clearly not one giant circuit. That wouldn't be sensible, because if you want to do any work on the overhead line anywhere on that route, you'd have to switch the whole circuit off. So instead, we chop it up into smaller circuits or manageable circuits. And we call those circuits sections and subsections. And the switching is the means by which we actually switch electricity on and off within those circuits. So that's all we're talking about today. So yeah, let's get into it. Hang on, sorry, skipped ahead too many there. So why do we need to look at it at all? So the current sectioning and switching practice, I'm not going to call it policy because there really isn't any policy. There's no standard on how to do this. But the current practice was basically codified in the 1960s, handed down from generation to generation, almost by word of mouth, not really written down anywhere in any meaningful sense. And so it sort of just evolved and emerged rather than being properly codified. So clearly that's not great. That's not because this stuff drives cost. Switching costs money, sectioning costs money, like anything. But also we found because of that, different projects have taken different approaches. You see different philosophies on Great Western to on even on Midland Mainline, TRU, and in Scotland, in other places. What tends to happen is it tends to be the local engineers driving their own policy based on their own experience and practice. They've got bitten by particular issues, so therefore they react to that. And if you have too much sectioning, you kind of think, well, you might think it's great. You have lots of little circuits. What's the problem? It costs money. More switching, more. These switches require power supply. They require SCADA. They've got physical equipment. A lot of them need separate structures. So it all drives costs, and not just capex either. It's also asset maintenance costs. If you've got assets, you've got to maintain them. You've got to inspect them. It's all cost money. So that's why having too much sectioning, too much switching is not a good thing. So we do quite a lot of work with Network Rail, with the Network Rail Technical Authority and STE on various aspects of reducing electrification cost. And this is one of the projects that we did with them. So they asked us to review the current practices and then come up with some recommendations as to what should be the standard, to codify what would be the standard way of doing sectioning and switching in future. And the main focus for us was on two-track railways, because if you look at the electrified network, most four-track railways, although we're going to talk about one of the few bits that isn't, Filton Bank, Paul's going to talk about that at the end, but most four-track railways were already electrified. So we focused very much on two-track railways. And the remit was to develop new proposals and new principles that would govern sectioning and switching. So how did we do it? Well, we started by looking at what we have today. So we specifically focused on three corridors that were electrified in Control Period 5. So the Great Western Main Line, obviously here in Swindon, we know that very well. The Edinburgh and Glasgow route via Falkirk, which was done in Scotland, and also the Great Eastern Main Line, which, although it wasn't an electrification in CP5, it was converted to auto-transformer feeding in CP5 for Crossrail, and therefore it reflected current practice rather than past practice. So what we did within that, when we analysed each of these routes, we looked at there are three different requirements that involve sectioning and switching. There are the requirements of the maintainers, right? There are what do the maintenance teams need from sectioning and switching? What do operations people need from sectioning and switching? There's a very typically very different things. And then what does the actual function of the system need? In order for the electrical system to achieve its basic functionality, what does that need to have in terms of section switching? So we looked at each of these, we completely compartmentalized. Trigger happy there. We completely compartmentalized those three requirements and looked at them separately. And then only at the end did we bring them together to say, okay, so what does that mean for a specific scenario? And you'll see some scenarios and some diagrams a little bit later on as to what that means. And then once we'd done that, we then developed a new rationale for what sectioning and switching requirements should be. And once we developed those principles, we needed to test them. Would they actually work on a real railway? So what we then took was a non-electrified line, in this case Birmingham to Bristol, effectively via Gloucester, and we applied those principles along the route to see whether it would work. And we did think we made some refinements when we did that, because obviously it didn't quite work, but it was pretty close. So the first section we looked at was on Great Western. We didn't hold the Great Western because that would have been very, very big exercise. So instead what we looked at was Maidenhead to Vauxhall Junction, which is a 4-track section. So we did look at one 4-track section just so we could make sure that we didn't want to develop principles that simply wouldn't work on a 4-track section. So we looked at that as well. So we looked at, there are the numbers, I'm not going to read them all out. You can see a fairly large number of locations, so it's a good statistical sample. Of those kind of 130 that we assessed, we found 21 that were simply either completely unnecessary or nice to have. Which, you know, if you've got loads of money, nice to have is great, isn't it? But if you're cash strapped, maybe nice to have doesn't meet the criteria for being needed. But we did find 43 that were desirable, so they're kind of sitting in the middle somewhere. And then you on a project you need to have a grown-up discussion about, you know, are they desirable enough to make it into the scope. Most of the unnecessary ones relate to loops, Reading Station, and sectioning of ATF. And we'll talk about loops and station and ATF sectioning shortly. I should add that with each of these that we looked at, we actually reviewed them with the local team. So we sat down with the Wales and West people, we sat down with the maintainer, the operator, the ECO was there. So we actually walked through our findings, and it was them saying to us, yeah, we don't use that section. We're never going to throw that switch. We can't see a scenario where we're going to operate that equipment. So moving on to GW 2-track section, Wootton Bassett to Stoke Gifford. So that's basically from just west of here in Swindon through to Bristol Parkway. Again, 58 sections, 19 of them considered completely unnecessary. Not by us, by the team that are running that railway and operating it right now. And 16 not essential. So that's a pretty significant chunk. That's a lot of unneeded assets. So again, you know, breaking it down to individual assets, you know, 15 isolators not needed and 15 more not essential, and most of them motorized, so most of them having associated power supplies, associated SCADA. That's a lot of money that we can avoid spending. Again, same themes come up: loops, stations, ATF sectioning. Kept coming up over and over again. Is why have we sectioned it like this? We don't need to. They're not needed. So some specific comments from the Western Route team. They said most of the switching at Bristol Parkway we're not going to use. If you're ever at Bristol Parkway, have a look around, because you can see most of them. There's quite a lot of switching just off the platform ends. Just consider that. Have a look at those assets. They're just going to sit there, not being used for the next 50 years. On the flip side, got real challenges at Chipping Sodbury Tunnel, where we haven't provided enough sectioning. So this is about getting the section. It's not about just saying no sectioning. It's about having the sectioning that the people who are going to operate the railway actually need. And it's quite difficult, because often on a project, I was working on this project at the time, and there was no electrification team to talk to. There was no, you know, the electrification maintainer didn't exist yet. So it can often be difficult to know what, and also the train operator, typically a train operator on a non-electrified route does not know how they want to operate it yet. So it can be quite difficult to get answers to the questions that you have as a designer. But these principles that we've put forward should make it easier to do that in future. So we then started to develop, we had some findings, we had some thoughts. We then started to develop some principles. And again, very much, I know we're all bored of hearing the term MVP now, but the principle behind it is a good one. So we tried to keep to that. Again, looking at what's the minimum needed for maintenance, what's the minimum needed for operation of the railway, and what's the minimum needed for correct function of the electrical system. Those are the three questions we were trying to find the answers to. So let's get into it. So these are our principles. This is what we're putting forward. This is what we're proposing that the industry uses going forward. First thing to do is to look at your isolations and what isolations do you need, and to separate them into two distinct categories. An isolation when there's a fault. So out there, something goes wrong, there's a fault. What isolation do you need to take immediately to keep this railway running? That's a fault isolation. And then possession isolation. We've got planned works, you're going in to do a track renewal, whatever. What isolation will you then need for that? Because they're very different scenarios and often very different isolation requirements for those two. And the key thing is you've got to identify your degraded modes during the design. It's often very difficult to do that because, as I say, often the local team don't know yet how they're going to operate this railway. So it can be difficult to get at that understanding, but you need to work out what your degraded modes are and write them down at the start. So I'm kind of giving you a teaser of what some of our findings are now, although we'll go into more detail on the next slides. Loops. So this is a loop. See a loop around the back of the platforms here. Don't need to be isolated separately. My generation of engineers, I'm sure everybody uses electrification. I see Johnny nodding at the back there. We've all been taught you must section loops. But why? When we started digging into why, we found something quite extraordinary, actually. We think that the reason why we've all been taught to do it is in the 1960s, they used to have loose fitted freight trains, right? So they used to have wagons, freight wagons, wooden bodied freight wagons with tarpaulins on them, right? And those tarpaulins would come loose during traffic. And then they had to loop the train. Somebody had to climb onto the train and secure the tarpaulin. That's literally why we're sectioning loops. It won't have escaped your notice that we no longer have those kind of freight trains. So why are we doing it? So no sectioning of loops in normal circumstances. There may be a specific location where you have a specific justification, but the default should be don't section loops. Similarly, platforms, isolating every platform. That's the traditional approach. That's what I've been taught. Sure, it's what you've been taught. Why? Now, it may be that the operations people want specific platforms isolated, but it should be their decision, not the designer's decision, to just do it by default. So the default is don't isolate platforms separately. Ask the maintenance and operations people what they want, and then act on that, but don't do it by default. Similarly, we've been busy sectioning the ATF every time we get to an auto transformer site. There's no need for that. It doesn't meet any maintenance or operational or electrical function need. It's just become the default. So we're saying, don't do that. Don't isolate at AT sites. You isolate at sectioning AT sites, but not at AT sites. And again, any additional sectioning should be justified. There should be a specific, ask them, okay, just set out the scenario when you're going to use this switch, when you're going to use this, what is the scenario where you're going to take this specific isolation? As long as you can write it down, it's fine. And as long as it's credible, not something that's going to be, if it's something that's going to be used once in the life of the equipment, that's not sensible use of taxpayers' money. But if it's going to be used, then you can do it. but don't do it by default. All the way through this, by the way, so broadly speaking, what we're going to present is in line with the Network Rail standard on sectioning 27,000, with exceptions. There are places where we say that standard needs to be changed. We'll call that out as we go along. Right, let's get into it then. So let's just work on this concept of fault isolation and possession isolation. So here we have a railway. We've got a double junction on the left. We've got a crossover on the right. For those of you who aren't overhead line people, the red and the blue are two different sections. And then the gaps in the lines, those are section breaks. So this red line, top center, is a subsection of the red electrical section. Right? So each time you see a gap, that's a point of isolation, effectively, in the railway. So if we look at the top one, that's just normal feeding. The red is energized, the blue is energized. In reality, there'll be switches across these gaps, so everything's operating normally. Now, let's say on this line here that's in green, we've had, I don't know, a helium balloon. A helium balloon has come into contact with the line, tripped it, and you've got a fault. Probably not a good example, but you get the gist. So we've got a fault. So we need to isolate. And if we didn't have any of those section breaks in, then we'd be isolating the whole track, or even if they were fed together, the whole railway. So that's no good. So what we've got there is a section break each end of the green line, so that we can just isolate that item and then run trains around the fault. So that's a fault. That's a typical fault isolation. With a fault isolation, you want to have as little railway affected as possible, right? And be able to run trains around. But when it comes to a possession, and one of the things that we found when we were talking to the Scottish team and the Wales and West team was they very rarely took a possession of one line, but not the other line. They generally wanted to isolate both together. And this is another thing we've been taught over and over again, to be able to take a possession isolation of one track only. But that's not how our railway is being operated and maintained at the moment. So don't assume. Obviously, again, ask the local people, how are you going to maintain this railway? Are you going to take possession of one line and then do work on the OLE while the live OLE next door to you is operational? And it's very rare that we do that. And it's generally safety that's driving that now. It's very rare to take an isolation of one road but not the other these days. So you can see the thing to do then with a possession isolation is to take both roads together rather than one road. So different requirements for faults and for possessions. So let's look at what's needed for the electrical function. And this is, I mean, I laughed when I saw this slide, Paul, because it's almost too simple. But it just to say, one of the key requirements is that every track has its own electrical circuit. We generally don't common up tracks, because if you get a fault on the up, you lose the down as well. So we're not sitting here saying we should common the whole lot up to save money. We keep that separate electrical section clearly. It's also a requirement for the protection system, which is quite an important influence on what you do with sectioning. For the protection system to work correctly, you need the two lines to be separated. At substations, what we need is, we do need sectioning at substations. And this, we're specifically talking about now the feeder station, so the substation that has the incoming supply from the grid, and also the midpoint substation. So that could be a midpoint AT site or a midpoint track sectioning cabin if you're on classic. So we will have sectioning there. You should try and align the substation sectioning, and it's usually a neutral section as we've shown here. You should try and align it with your isolation requirements. We don't, and we have got examples on the network where you've got a substation with a neutral section, and then half a mile away, we've got an insulated overlap with sectioning. That's wasteful. If you can avoid doing that, merge them, common them up, make sure that the isolation limits are aligned with your substations. And again, we generally provide neutral sections there at the feeder stations and at midpoint. We're not proposing any change to that policy because having those neutral sections allows you to reconfigure the feeding system when you need to. In terms of neutral sections, we didn't actually, the whole neutral section question was not in our scope to look at. So we're not getting into the, should it be a carrier wire, should it be a short or a long neutral section? We didn't look at that. But you do need a policy on that. Project needs to have a policy, clearly. As always, you have to make sure that your neutral section is located in such a way that trains moving through it, having stopped at a signal, can get through the neutral section without being stranded. And if they stop beyond the signal, that they don't get stranded. But again, we're not proposing any changes there. One thing I think we're not very good at, and I've certainly personally been on the receiving end of criticism from train operators for doing this, and I think it is a weakness in the sort of design community, is finding out how neutral section location near stations affects sectional running times. So typically what we do is do our best to locate a neutral section. Often we can't, it needs to be near a station because that's where the substation is. But then after having done the design, we then present to train operators and they say, that doesn't work for us. That will cause us a major operational headache. So make sure you get the operators involved at an early stage, although it can be difficult to get engagement, but do try and make the effort. Looking at, so that's feeder stations, looking at substations, intermediate substations, we are saying, what we're basically saying is only provide sectioning if the protection system needs it. If the protection system doesn't need it, then don't provide it. And Paul will talk a bit more about that later on when he talks about rationalized switching. So the next scenario we're going to look at is crossovers. So just simple two-track railway with a crossover. And this crossover doesn't have a turn-back facility. What I mean by that is, at no point is anybody going to move a train from the blue track across the crossover to the red track and then turn around and drive the other way along the red track. That's what turning back means. Again. So if you haven't got a turn-back requirement, then this is how I was trained. This is what I would call this old school crossover sectioning. So basically, you put a section brake on the open end of the crossover on each side. And what that allows you to do is, if you've got a fault on the right-hand side on the blue track, you can isolate that fault. And then if you've got bidirectional signalling, then you can run a train from the blue track onto the red track. And then somewhere down here, there'll be a crossover to regain. In fact, ironically, I got stuck outside Swindon this morning on my train, and I was watching on live signal diagrams, and that's what they were doing with the trains east of Swindon. So that's what you do if you've got no turn back requirement. And that's really not any different to the way we were doing it 20 years ago. Although I have seen some recent schemes have actually sectioned in 4 places, which again is two additional overlaps, 2 additional switches aren't needed. However, if you have got a turn-back facility, so let's say you do want to run trains from the blue track over the crossover onto the red track, driver goes to the other end of the train and then heads back. You typically find that near stations. It's typically what they do. If you've got that requirement, then it changes a bit. Then what you need to do is, as well as still provide one here and here so that you can use it, you can work around a fault on the blue, but also provide a section brake here so that you can, if you need to have a possession isolation of everything north, that you still retain the ability to use the turn-back facility for electric trains. Again, this is where designers have to do the hard work of talking to the operators and understanding how are you going to use this railway. which I do think is something we don't always do. So now let's build up the complexity a bit. Now we've got a pair of trailing crossovers. So again, you can use the same principles now to start to build up. If we haven't got a turn back facility, again, this is the old school way. This is the way I was taught to do it. You do your 3-point sectioning. You section at these 3 points, and it's just an extension of the previous principle. Now we can operate a train from the blue track on the red and along here, and then come back somewhere else. But we can also do it the other way. If there's a fault here, then we can bring a train over here, isolate there. So no difference. Again, you can see now with the turn back, it's the same principle. If you've got a turn back facility, provide a common sectioning point on both lines, on both sides. The next scenario is a diverging junction. So we've got a major route and a minor route. See that there? We're proposing that we should provide sectioning on both legs. The sectioning should be at a common point for, in order not to have residual hazards. If you think about why we have this, it allows for fault isolation on either track, on either leg of the junction, but it also provides that common sectioning point for possession isolations. We can see that the major route there has been isolated for a possession. It sounds obvious, but it does need to be thought about. There's no point providing sectioning if the sectioning limits are going to sit outside the possession limits. If that's the case, that sectioning is never going to get used. The sectioning has to be at the same location or in board of the possession limits. So a designer, you need to do the hard work of understanding what possession regime is on the railway. So now let's just take that principle and let's add some auto-transformer feeders. So where we've got auto-transformer feeders, we are proposing that the ATF is also sectioned and the sectioning locations are in common with the overhead line. But if you, let's say, so that's got obviously both routes are AT feeding. The major route, the minor route, both AT feeding. Let's say the minor route didn't have AT feeding. In that case, don't section at all. There's no benefit in sectioning it there if it's not, if the ATF isn't splitting and going in both directions. And where we need to, the ATF should be able to be isolated from the feeder station to the midpoint substation. I think we show that a bit later on as well. Yeah, so next slide. So now let's have a look. Let's look at AT feeding at substations. So what we have here is an AT feeder station on the left, or it could be a midpoint AT site. So we've obviously got the neutral section on the overhead line, and then we've got a sectioning AT site on the right. We've got overlaps on the overhead line, and we're proposing that we do have sectioning for both of those locations. But for an AT site without sectioning on the overhead line, do not provide sectioning on the ATF, which is not what we've been doing up to now. We couldn't find anybody who was going to use that sectioning. So again, if no one's going to use it, if you can't find somebody who says, I'm going to use it, here's why. That's a key principle. I think previously, what we've done is we've asked, what sectioning would you like? And then people have put forward sectioning needs, but without writing down specifically how they're going to use it and when. I think that's what we're doing now, is flipping it around and saying we're not going to do that unless you can justify it, unless you can write down your rationale and your justification for it. And that justification needs to be, I'm going to use this more than once in 50 years. It's going to get used multiple times, great. It's going to get, if you can conceive of a scenario where you might have to use it, maybe, that doesn't pass the test. So there we go. There's an AT site. No section. Right, so as you say, loop lines. Do not section loop lines unless you have a specific reason and a specific justification. We did find a couple of loop lines, didn't we? I think that they had specific logic for wanting to section. But the vast majority of loops that we looked at on the ENG route, on Great Western, nobody could come up with a scenario where they were actually going to practically use. So obviously we're going to propose that that standard gets challenged and amended. Similarly, we've got in the habit of just sectioning stations automatically almost. But if it's a simple station, 2-track railway, facing platforms, pylon platforms, don't section it. Don't section it unless the train operator or the maintainer has a specific reason, a specific scenario. So here's a slightly more complicated section. Again, a couple of loops. Only if maintenance really want it and can explain why they want it. Once you get sort of to a level of complexity beyond this, more Swindon example, slightly more complicated station, you just need to think about the operational requirements. How is that station going to be used operationally? And then therefore, what's the minimum sectioning to achieve that operation? So again, you need to work with the operator. So there we did find, I think Glasgow Queen Street was one where we had quite a bit of debate about which platform groups should be capable of isolation. They didn't need every platform individually subsectioned, but they did want groups of platforms to be sectioned to meet the, to work with the maintenance access that they had, and that's perfectly legitimate. We're not here saying no sectioning. We're here saying sectioning where it's really needed, sectioning where it's going to get used. Sidings and depots. So essentially, for a simple depot or siding should have its own electrical section. We're not, nobody would be crazy enough to say that the depot should be on the same section as the main line, because as soon as you take an isolation on the main line, you've lost your ability to maintain the trains, which is great. So yes, it should be separately sectioned. Often they do have their own electrical supply these days. That's increasingly the norm. That's fine. There's good logic for that. Where justified, you might need to add these additional 2 sections that we see in the circles. So if there's a fault over on the right-hand side, right, and it'll essentially take out your access to the depot. So great, the depot's got its own supply, but you can't get trains there. So often they'll provide a crossover, the dotted one, in which case you clearly need those two additional section breaks in order to either allow the possession to happen or isolate the fault and continue to allow access to the depot. So that's sensible. Again, what do you need to do operationally? What do you need to do with your possessions? Right, I think that's me. Over to you, Paul.
Thanks, Gary. Good afternoon to you all. So I'm Paul Hooper. I'm a technical director here with Atkins Realis, but I'm based in York, so it's always interesting to come and visit these other sections. And I'm a regular at the PWI in York, so good to be able to share and work across sections. My background is generally electrification, and it goes back to East Coast Mainline, original electrification back in the late 80s. So just showing my age a little bit, but yeah, some of these principles. Yeah, one of the challenges I put to all engineers is forever ask why. We all say we learn something new every day, but the way we learn is by asking why we're doing things. And throughout my career, I've tried to challenge the way we do electrification as to why we're doing it, rather than that's the way we have. And for any of you as engineers, if the answer you get back for particularly when you're more junior, but at any stage in your career. Oh, that's what the standard says, or that's the way we do it. That's the way we've always done it. That's not a good enough answer. So just go for that dig. And if you can't get the answer from the individual you're talking to, go and find someone else and ask why. And if you don't get a satisfactory answer, then you come back and start challenging it and say, well, is there a better way of doing it? And a lot of this really started from what we've been talking about here was when we were looking at the Midland Main Line, which has been ongoing for, I've been involved in just the extension north of Bedford for well over 10 years now. The loops was the thing that challenged me, and there was this group standard that said, you've got to section the loop. It says so in this group standard. And I said, so what? We're a network rail standard, not a group standard. I said, yeah, but why are we doing it? When do they ever get used? How often do they actually get used? So we did put in a challenge to the standard, and it's still sitting there. We've had positive feedback that yes, it's not really necessary, but the standard has been reissued since, and the clause is still there. But it did start that conversation with the technical authority that we then led into this work. And they said, well, you're challenging all this, yeah. Put your money where your mouth is, sort of thing. Come back. So these couple of slides I've got here, I'm not going to read them all through. You can have a look through it. But basically, some of the sorts of questions that you should be asking at the beginning of a developing electrification system. So what is the isolation strategy? And it comes back to this, trying to understand the way the railway will operate. So why are we doing things rather than this is the way we do it? So if you've got a 2-track or a 4-track railway, how do the isolations work? Is it in pairs? So you've got an up and a down and an up and a down, like most of the Great Western. So you've got the mains and the reliefs, or is it more like the East Coast, where you've got 2 ups and 2 downs and the slows are on the outside? So understand how the railway actually will operate. And are you is there a requirement for that single line isolation? And most of the safety directives now are saying, if you're going to be working on the overhead line, you need to have both lines isolated, and you need to have parallel points at the end, which is what has developed over the years. And we have all these paralleling points. We isolate both lines at the same section. We're putting a bit of sectioning on one line. Oh, we've got to do exactly the same on the adjacent line, without actually understanding why. So that was this concept of the fault isolations, which is only to keep the railway operating while you clear that fault. When you come in to do some repairs, if there's been a rip down or whatever, then you extend, if necessary, what the limits of that isolation is for your possession isolation. But for the immediate fault, but do we need to have it as small as possible? One of the things we did look at was how many trains you're going to trap. If you've got one train that's faulty and you suddenly, or a fault in a section, how many trains are you going to get trapped in there? And actually RSSB did some work on this a few years ago and came to the conclusion that providing the extra sectioning did not pay over the life of the project, or very, very few circumstances. When we're looking at the Glasgow Edinburgh, as Garry was talking about as well, there's one section there that is a particularly long section, and the operators could see some benefit in having some intermediate sectioning, just to split up a very long section, so they didn't have a large number of trains potentially trapped in a single section under a fault scenario. But yeah, understanding how the train's actually going to get around that fault, and if there isn't an alternative route, then actually by the time you cleared the fault or got the possession, is probably as quick maybe as trying to recover some of those trains. So lots of things to think about, but a few questions to ask. What's your isolation strategy? What are your possession limits? How do the rules of the route work? How do the maintainers take their possessions? Does that need to be challenged when they go into an electrified railway from a non-electrified railway, or does it maintain the same current practices? Some risks around inadvertent energization, and where do your pantographs potentially, if a train's misdirected, overlap with go through an overlap or section insulator and liven things up. How do we manage those scenarios? What are the emergency isolation requirements? Some of these things, just tease them out of your the operators and the maintainers. And then, what are your maintenance strategies? What are your access points? How do we make sure that we can maintain that? And then a few other items, which Gary's talked about, the site access to depots, but also what are your interfaces? How are your stations going to operate? Key bit of what Garry was talking about. So that's really the electrical sectioning, but it's all tied in with the electrical feeding. And the technical authority for a long time have been challenging why do we have quite so much equipment at our substations. So we have circuit breakers. When I first started on the railway, you had a relatively simple tin hut. It was before the days of AT, so it's classic feeding. You had a circuit breaker that would feed through a roof bushing, a bare feeder out to the overhead line, and then you'd have an overhead line isolator to feed the overhead line, and that was about it. Started with to integrate more and more safety precautions, putting isolators within the buildings, lots of cable feeds, which I don't necessarily disagree with, that they're there for good reasons. But more and more equipment seems to have built up around substations. So the technical authority was challenging, and as part built into the remit that they gave us as to why do we need all this? What's it actually doing? So it's that why question again. So we analysed it. We spent quite a lot of time, and we following various different processes to try and understand exactly what is the function, why do we need the equipment that we've got, and then having developed that, how can we find maybe an alternative or a more cost-effective solution to providing facilities. So we looked at the basics of the electricity at work regulations. What are the functions of taking an isolation? So you've got to disconnect from the source of the supply, and the isolate can be a different function. They can be combined with that disconnection function. You've got to be able to secure that isolation, so you can't have someone come along and just close the switch again and re-energize it. So how do you actually go about that securing? Traditionally, we've used mechanical interlocking and padlocks to prevent anyone operating switches. How do you then apply the earth and then proving dead? So all those different items needed to be built into any system architecture that we developed. So we broke it down to begin with by looking at the catenary system on one side and the bus bar in a substation the other, and what are all the bits in between, and where does the boundary between traditional P&D staff and overhead line staff lie. And we looked at moving that about a bit, and through iterations of this work, it changed slightly. But basically, we need to be able to isolate the bus bar from the catenary and make the bus bar safe to work on while you're still running trains. Similarly, you might want to keep the bus bar live, but be working on parts of the catenary. So you need to be able to earth up the catenary and keep the bus bar live and make them secure and be able to do the tests. So that was just a very simple block diagram that we then took to develop how can we simplify the substations. So we actually found that we can get rid of nearly all the substations. We can actually deliver those functions with load break isolators. So combined with modern SCADA systems, 61850, IEC 61850 substation technology, we can link all our isolators up, fast acting, and this is a very basic architecture for a typical railway. This isn't going to network rail standards as from today. Don't read anything further into that. There are all sorts of other issues that will need to be to evolve, particularly your emergency isolations. How do you actually go about isolating? But in effect, you can use your circuit breaker on your incoming feed. That can wipe everything out to clear any fault. You then use all your isolators around where your fault is, and you can then reclose the circuit breaker. That can all happen in very few seconds, 2 seconds or less. So that physically can be done with very little disruption. The processes and the acceptability is a long way off. But so this is all about how can we minimize the switch gear as well. So some of these extracts are very similar to what Garry was showing. We've superimposed the switching arrangements and the earthing requirements. So that's sort of full system, typical sort of layout between 2 feeder stations, a midpoint. We've lost the earths on that, apologies. 1 or 2 things seem to have gone wrong with the graphics, but you've got a midpoint sectioning location in between, and then you don't really need intermediates, because the function of the intermediate is to provide paralleling and to provide isolation. You can do that through a paralleling isolator and then bypass around your overlaps. So we've broken it down and looked at what is the minimum sectioning that's required for different functions. So again, we've got these two different types of sort of crossovers. One where we've got the simplified version, where there's no need to take a possession or because there's no turn back facility required. However, at this one, we're assuming that there is, and we'll take possessions either way. So again, it's understanding the possession strategies and the operations of the route. And we then tested this layout by saying if we had a fault and we've gone through every different combination of a single fault. So if you had a fault anywhere on the line, we've tested it. Can you feed around it? Can you reconfigure the equipment to maintain the railway around the fault, but also to isolate it? So we got all these red circles around those isolators that would need to change their position in order to isolate that fault. So we had a fault on this section. 4 isolators would change their position. You could then reclose the circuit breaker and you would recover the situation. So we tested that, and the principle works through every single subsection on that layout. And then the possession isolation arrangement, again, you can have all this. There's no point in putting an isolation halfway down here because operators are never going to work. So as long as we understand, if we've got the ability, and part of the challenge we've had back as part of the discussions with the maintenance teams. But you've got to get someone to drive a vehicle. They, to operate the switches here. They've got to drive, and if this is 10 miles away, by the time they've got there, you've missed the possession, and you've wasted so much time. So again, it's all combined with what is the modern control technology, remote securing of Earths. So there's lots of things that need to go into development still before these sort of principles can be applied. But working through the basic principles, we've demonstrated that it's possible. So here again, we've got earth switches as well, so we can earth out. So these are the circuit main earth CMEs that we've seen. And if we start adopting the principle of you only need intermediate earths around your work site, as long as you've got the limits secured, you can then apply your local earths. You don't have to earth up every 400 meters throughout your possession. You just put intermediate earths around your particular work site, and then you've got your circuit main earths that prevent re-energization. So if you've got parallel routes, if it's only a 2-track railway, then you don't have the induction issues, but actually your local earths are to protect you against primarily induction in the overhead line. You've secured your isolation through your CMEs, which meet your electricity at work regulations. So as long as they're secured, there's no way of energizing this. So your intermediate earths are just to protect the workforce against induction, not against re-energization. So that's what these earths at the end are for. So again, we looked at all the different possession combinations, and it looks like I'm running out of time, so I'll move on. And we can achieve them all through that arrangement. So the logic stood the test. But we weren't satisfied with that. And as Garry said, we also applied the sectioning, but also a little bit around this electrical processes to the route between Bromsgrove, so extending on the cross-country route, Bromsgrove down to Westerly Junction. And just an extract of that, the Gloucester Triangle. So it actually starts getting a bit more complicated. But again, we've worked out that some of these we started to call track sectioning locations because that's the effective arrangement, but they can be tied in with the junction areas that allow that operation to be maintained. So we developed the system that works for the Gloucester Triangle. We then looked at the possession isolations, because each of these we know we can isolate from under a fault condition, but for a possession isolation, you'll take, if you wanted to take a possession of Cheltenham Spa Station, then your limit of isolation would be all the way back to these sectioning points here, because you can't operate trains in this section. If you've got the station out of use, there are no crossovers, there's nowhere that a passenger train can go. If you've got freight trains, then you have to consider where might they be. If they're electric freight, they're going to go into a siding somewhere or a freight depot, then you do need to look at that as well. But most of the electrics are, passengers at the moment. So just for Cheltenham Spa, you'd take an isolation at this point. If you wanted this junction out, then that bar there shows the limits of possession. And so we could reproduce these. And what they actually did this a lot more in Scotland. They looked very closely at what their possession limits were and developed their electrical sectioning around with their possessions. Whereas Great Western seemed to be a lot more about, let's put more sectioning in all these scenarios that Garry was talking about, or we think we might need to have that platform isolated. So this concept of possession limits was not developed to the same extent. So it is possible. So again, we're not saying you can't have any additional sectioning. It's just, let's start with the basics and then develop more that can be justified rather than the other way around. So moving on quite quickly, one of the other things that we found difficult and we were questioning a long way back on the Midland Main Line was the arrangements for switching. Do you have portal booms? Do you have the Great Western area where you've got very high bare feeds? Can we run bare feeds on candlesticks? All these issues about limits of leaving residual live equipment that's exposed, that workers, and there unfortunately have been many incidents over the years of people approaching live electrical equipment. But the basic principle is possession isolations, where anyone's going to go near the overhead line, then both tracks are isolated on a 2-track railway. We've done some economic studies. We worked with SPL to get their cost. Don't put in a portal boom if you don't need it. Use the existing structures. You don't need to go mid-span and put in special feeder structures like you have done on the Great Western. Use the registration arms, the structures that you need for the overhead line, and just extend them. So aerial bare feeds generally don't need to be as high as on Great Western, and we propose that this should be the default arrangement for all switching sites. There will be exceptions. There'll be 4-track sections. There'll be all sorts of other complications. Also, we looked at where you've got existing portal booms anyway for other reasons, then you might want to make use of them. But that worked for the paralleling locations. We basically looked at 2 scenarios: the paralleling location and then the bypass location. So this actually probably doesn't look that dissimilar to an old Mark III type arrangement at a substation. But again, we can put all the switches on the same side, which is not the way we used to do it, for safe access. They're all motorized. They're only colored red and blue just to differentiate the two. We looked at the Dreicher type switch with the flexible drive, whether putting them on the boom would be more cost effective. But the preferred solution overall, without being remaining agnostic about the particular switch. We're not saying it's going to be a Morris line or a Dreicher or anyone else. It was the principles. We have effectively used a vertical throw switch just for the illustration, but that doesn't necessarily have to be the case. So that basically, we're looking from the overhead line perspective to have a default system. Gary's got lots of meetings to go to. By the looks of things, it's not come up on there, so that's all right. So, summary, sectioning rationale, this was the sort of conclusions we came to at the end of our study, that we were suggesting that take the sectioning rationale that Garry talked through, develop that into a network rail standard so that it can become the default. Those switching arrangements I've just showed, we propose that those get incorporated into UKMS. I don't believe they have yet, and that all the wide range of different options that are there get withdrawn or at least get restricted, and there's some sort of hierarchy of how you go about selecting your switching solutions. And then we propose further work, because all good consultants say, give us some more work once we finish this bit. So we didn't look in a lot of detail at AT systems and the protection and control arrangements that are associated with switching will need further development. But we're in the Wales and Westerns, so we couldn't really miss the opportunity to recognise that there's still more electrification to be done here. So some of the learnings from what we've done and also the experiences, what do we need to consider about potential future electrification on the region, on the route? So Filton Bank and Bristol Parkway is quite complicated. So I think you can probably treat the 4-track railway section as 2 2-track railways wherever possible, and then consider specifically where they differ, where they link together, where you've got crossovers between the mains and the reliefs. And then we propose further work, because all good consultants say, give us some more work once we finish this bit. So we didn't look in a lot of detail at AT systems and the protection and control arrangements that are associated with switching will need further development. But we're in the Wales and Westerns, so we couldn't really miss the opportunity to recognise that there's still more electrification to be done here. So some of the learnings from what we've done and also the experiences, what do we need to consider about potential future electrification on the region, on the route? So Focus on that degraded mode operation. So understand, how does the surface work? How do trains operate when you're degraded mode? And then develop the sectioning around that. So build it from the bottom up, put the minimum in rather than top down. Again, define those fault isolations and those possession limits. So right up front, say, where are the possessions now? Do we need to have all those combinations of possession limits? How does that fit in with train operations? And also the electrical sectioning. So you can take a possession, an isolation beyond the limits of the possession if absolutely necessary, but then actually get the possession extended to match. Don't split them long sections into lots of small ones just because that's perceived to be easier from an electrification perspective. That can have significant costs. Safety considerations about adjacent line operations and where they're working. Particularly at Bristol Temple Meads, you've got through lines at the moment, so assuming the layout doesn't change, you've got 3 lines between 2 platform faces. How does that actually operate in practice? So that might trigger some additional sectioning. I'd be tempted to go the other way and say, why do we need to put any extra sectioning in at all? Under what circumstances will that be used? Oh, we're going to clean the windscreen on a vehicle. Is that really necessary? Does that need a separate isolation? I don't believe it would be. If you're taking isolations every time you want to clean the windscreen, you've got a real problem in your operating practices. So things like that, just challenge those requests, make sure they're justified. The triangle just to the east of Temple Mills, Temple Meads, is a challenge, but look at how does that actually operate in practice? What are the connections? How does the junctions work? The depot connections as well, and also how do you allow for future electrification? Then finally, the two track railways you've got potentially, hopefully, Didcot to Oxford and Cardiff to Swansea. Again, follow the proposed rationale. It'll fit that much more neatly on a 2-track railway. Again, focus on the degraded modes of operation, noting that some sections are bidirectionally signalled, other sections are not. So if you haven't got bidirectional signalling, how will the service actually operate in that degraded mode? Do you need to put in facilities for it or not? Again, adjacent line operations, possession limits, depot connections, future electrification, and or triangle down at Swansea, be a challenge. And again, that key thing, challenge all sectioning requests that don't align with the rationale. So we're not saying you don't include them in the design. There will be very good reasons why you've got to do more than the bare minimum. But just note that in your design logs. We're doing this because there's a record there, and you can have those discussions with the operator. I think it's hopefully not overrun by too long. Don't think we've left too much time for questions because we don't want all those difficult questions, but over to you, Simon.
Okay. Thanks very much, Paul and Garry. That's brilliant. We have got a couple of questions online. Is there any questions in the room? I'm going to take Preston and ask my question. Actually, it's Graham Stubbing's question. I'm going to steal it from him. Any of the loop, I mean, he's found that some of the loop line sectioning in the switches, they generally haven't been used ever until the maintainer comes to do their maintenance check of the switch and then puts a fault on it. And then that requires them to go out and do work. I wonder if you had that feedback from any of your discussions.
Yeah, if it's not there, it can't have that fault.
Yes.
So yeah, but even then, you can do the maintenance on it by taking the wider possession.
Mm-hmm.
You're not going to. You've generally got section insulator in a loop, 2 section insulators, mm-hmm. and 1 isolator. Yeah. All that need more intense maintenance than a simple equipment.
And the only thing that's ever been used is the fault as they've gone to maintain it.
Yeah. So generally that was our finding. Mm-hmm. Garry mentioned that in Scotland there was one particular loop that is adjacent to a depot that we could understand.
Okay. Yeah, so that's part of the justification of that specific. Yeah.
Gary mentioned about neutral sections, which is similar. We had arguments, if we're going to maintain the neutral section, we need to have an isolation either side of it. So let's have the extra sectioning just either side of it. No, look at the way the railway actually operates. And with the remote, the remote locking is a key, remote securing is a key part to this. If you can secure that isolation from much further away, then that enables you to take a much longer isolation. So if you're working on the neutral section, yes, you've got to have either side of it isolated. But as soon as you've got that isolation, how can you run any trains around it? So you'll find that where you need your isolating point for your operations and your possession limits will coincide. You just need two. So that example we had at Bristol, at Gloucester, if you're taking an isolation to work on the overlaps, then it extends. You need two possessions back to that, and you look at that.
Sure.
But yeah, good point. Thanks, Graham.
Yes. And then, so we've got two questions online. So, Rui, would you like to come off mute and ask your question?
Hello, Gary and Simon. Are you okay?
I agree.
I hope so. So my question is very simple. It's the question of the loop in the station. Normally, the people say we don't need the loops in the stations because we don't isolate it. In the old times, we use it to park and to make some maintenance in the wagons or wherever. In this moment, what we say that, according to the presentation, is that we think it's not necessary. My question is, according to the requirements, will be something like preparing the OLE to have it in future if needed, or only be a straight line?
I think if I've understood you correctly, Rui, we're not saying it's not necessary. We're saying the default is that it's not necessary. So it depends on the complexity of the station and the way the station will operate. But a simple 2-track or 4-track station, as was illustrated on Gary's diagrams, how do you actually benefit? What are the benefits of isolating that loop? And when is it actually going to be used? So if it can be demonstrated that actually there are scenarios that you would need it, then great. But all the discussions we've had with admittedly it's network rail operations side rather than train operators, has been, when do you actually take an isolation in normal operations of a loop through around the back of a platform? And it doesn't happen. Very rarely does it happen. So if your maintenance for and if it's an extended loop, then you're starting to come into a sort of 4-track section, and you're saying, but even then you then got the adjacent line operation issues. Why do we need to isolate that platform loop separately from the main line? And if there's good justification, if you're saying, well, if we put a failed train in there, but do we actually put failed trains in loops and then isolate them and then go on the roof? I don't think we do. So I'm just saying,
the last time you saw someone propping a ladder up against an electric train in a station. I travel a lot by train. I've never seen that happening.
There might, some people might say, oh, we've got to maintain the fascia on the on the canopy or something. When's that going to happen? Are you going to be doing that under normal operations? Do you really need to do that when you're adjacent, the other side of the island platform is in operation? Or would you just make sure you plan that to be done at an overnight when you can take the wider isolation? It's just those sort of challenges. We're not saying you can't have it. Just let's try and understand why, and then justify that extra cost, that extra maintenance that goes into it, the extra equipment that it includes.
Yeah, the only my question is, sorry.
No, carry on.
My question, it's it's because in some of other countries, what happens is that sectioning, it's decided by the section, let's say the chief of the station, and they have only the key. It's a manual one, only on possessions, the very rare cases they can use it. My question is, can we, when we do the OLE runs, prepare that to in future have it, or we simply ignore it and after we put an isolation? Section isolator or whatever.
Thanks, Rui. I understand the question a bit better now. I think this is a wider thing that we see, that we do a lot as an industry. We say, what if in future we want to do such and such a thing? We spend too much money on what ifs. So I can think of what ifs on GWEP. They're almost certainly never going to happen. We've got long masts on Reading to Newbury in case we install ATF maybe one day. And that was, to me anyway, a waste of money. We shouldn't have done that. We could have been much more intelligent about providing future provision for ATF without installing extra additional steelwork. But I think we are too fond in the industry of trying to get our crystal ball out and imagine what the railway might want to do in the future. Let's leave that for future generations to spend their money wisely. We need to spend our money wisely today.
I think there's a good example, a bit more local to home for me, of that, Rui, that might help. As part of the 3-tracking project north of York, and they're putting in a 3rd track, they've had to change the sectioning around the station to enable that and for enabling works. So that was done last Christmas, but they actually installed the sectioning because they now know exactly what they want and what it needs to look like. If we'd guessed that 20 years ago when we installed the original and said, oh, there might be a 3rd track in here, we need to allow the sectioning to cater for it, we'd have probably got it in the wrong place. It wouldn't have met the current project. So I think if there's, overall the extra costs that we're putting into electrification for those what if scenarios, when they come along, you have to accept that there might be a slight additional cost. I've seen it not in the UK, where a future provision for a turnout in a tunnel was put in, and the allowance was built on the original tunnel. When they actually came to build the extension, it didn't suit the revised alignment and the junction geometry that was wanted. So a lot of that extra cost for that tunnel that was built in for that what if scenario was effectively aborted, because when they came to do the extension, the geometry didn't actually work with the track layout. So I think we can try and be too clever sometimes if we're not careful. Good question.
Okay, thank you.
Thanks, Rui. And then I've got there's a question from Camps. I think it's a bit tongue in cheek, but Camps, would you like to come off mute and ask your question? You might want to try and share your diagram if you're able to share your screen.
Oh yeah, I might be able to. It's basically one of the requirements in 27000 was that Network Rail specified to provide the facility for switch maintenance at overlap and SI locations, and things like your typical insulated overlap where you've only got one normally closed or normally open switch becomes very complicated arrangement to try and modify to provide sort of this functionality. I was wondering if you've come across any locations where that was ever a reasonable thing, considering switch maintenance is once every 10 years typically.
I think I have seen that diagram before, but it's not something that I would really support. I think it's putting extra complications in that creates extra equipment that needs to be maintained, and you get that sort of domino effect. Every time you put something in, you say, oh, we need another section insulated just beyond that, so we can maintain the one that we put in to maintain the one before that.
So that once every 10 years. So we're proposing to install an arrangement that's going to get used 5 times in the entire life of the equipment. That is not sensible use of money, is it?
I think we need to ask how do we, what needs to be maintained, how will it be maintained if you don't have that functionality, that additional functionality. So if that means you've got to take a longer possession either side of it, it's a bit like the neutral section I was just talking about. Look at that and say, is that practicable? And if it is so critical that it's not, then that should be a special, and that can be justified. But it's that default function that I think that's overcomplicating things as a default scenario. But yeah, it's another of those elements that maybe have crept into a standard that's worth challenging.
Great, thanks.
Thanks, Camps. Right, is there any last questions in the room? I appreciate that it's very tight on time. So, sorry.
Garry, Paul, thank you for the presentation. Really interesting. Just another bolt on to kind of what you have done. Did we think about overruns and kind of the discontinuous electrification, which is going to be more relevant in times to come? And what is the kind of the switching needed over there? Because again, it is very inconsistent. And then even the construction, the temporary requirements as well, like do we put 2 permanent earth sections, 3 permanent earth section overlaps? Is there something to?
No, we didn't look at that. I think it raises, what's next? Maybe that was one of the conclusions we just said, look at in a bit more. I think for me, the discontinuous element is really interesting. I think we've got to understand that, to me, there are two very broad, there are lots of different types, but there are two key bits of discontinuous electrification. One is the short discontinuity, where you have a cable connecting through a bridge or whatever it is that requires that discontinuity, which needs to be treated. Just that discontinuity, understand quite what the complications are, how you're going to manage that cable. But from a starting principle, I'd say you just treat it as a continuous part of the electrical subsection, unless there's reasons why not. The other type of discontinuity is where you have a significant discontinuity, and effectively, to me, that's sort of an end of line type scenario, and then you start a new bit of electrification. A bigger challenge there, I think, is how do you have the security of the supply? What are your N-1 in particular type scenarios? How are you feeding it under those scenarios, rather than anything particular around extra section? Is sort of my immediate reaction.
That's discontinuous, but I think you're possibly thinking about more about power changeover zones, which you're right is basically a brand new area that there are no standards for at the moment. And I think the industry would benefit from doing a similar piece of work to what we've done for continuous, for that end of continuous electrification and into a diesel, or in future battery. Just pure battery area. That is definitely an area that needs some work doing, some principles setting out, some standardizations. At the moment, I think every project, again, is just doing their own thing based on what they feel is correct, but not necessarily against any kind of common principle. So it's definitely an area for further work.
Yeah. Other areas of sort of overrun protection, I think we address.
But when does overrun protection become changeover zone?
There's a lot of issues, I think, around. Again, it goes back to what are we trying to do? What are we trying to actually achieve? So some of the principles of allowing for future electrification of junctions is one element, but also, what are we actually trying to protect against? What are the risks? So I know there were, traditionally we've been running all sorts of extra overhead line equipment down junctions that are not going to be electrified, just in case a train might happen once in a blue moon to actually be diverted down there. And if it does, well, so what? Unless it's going to cause some catastrophic damage, why are we providing extra protection? Or how else? I don't know how much you were involved in the Midland Main Line, but we did quite a lot of work around understanding principles of diverging junctions as opposed to overrun protection. But that's where the terminology can get misleading as well.
Yeah. Okay. So thank you very much. Well, I'm going to call the meeting to an end. We've overrun slightly, but thank you very much, Paul and Garry. If we could thank them in our usual manner, that'd be brilliant. Very informative talk. Thank you very much for that. Thank you very much, Alex, for sorting out the camera and doing that. Excellent work as always. So hopefully we'll see you at our next section meeting.